Hey folks, in this video we're talking about balancing chemical equations. Now, there's an evil wizard behind you. No, there might be, whatever. Anyway, I want you to be able to explain the importance of balancing chemical equations, and I want you to be able to balance chemical equations. And I want to look at a baby platypus. Okay, let's do it. Why should we balance chemical equations? Well, chemical equations need to be balanced in order to work. Like, if I said take bike wheel plus frame to make bike, that doesn't work. You get a bike with one wheel, and that's stupid. Or if I said take magnesium and bromine, and put them together to make MgBr2, that doesn't work either, because there's only one bromine atom on the reactant side, and there's two bromines on the product side. And that's not cool, dude. You can't just create atoms out of thin air. Who do you think you are? Like that blue guy from Watchmen who's like, poof, poof, matter? That's not you. Look at that. That's not you. Anyway, if we want to make balanced chemical equations, we want to put in coefficients. So I can put a cool 2 in front of my wheel, a coefficient, and now I have an equation that works. A bike frame plus 2 wheels does give a real cool bike, like that one. Or if I take a bromine and I put a 2 in front of it, now this equation works. Magnesium plus 2 bromine atoms gives me magnesium bromide, and this is a balanced equation. This is kind of stupid because bromine is a diatom, as we know, and likes to come in twos, but whatever, deal with it. So let's keep talking. Important stuff to know is that when we are balancing chemical equations, we are never, ever, ever going to change the subscript. Like, you may have looked at this initially and been like, dude, just make it Br2. That's how you find bromine. But we never change the subscripts on a chemical equation that we're given. And the other thing we need to know is, very importantly, the number of atoms on each of each element, I should say, needs to be the same on both sides of the equation. You are not that dude from Watchmen. You cannot create atoms out of thin air. So we need to have the same number of atoms on both sides of the equation. They're going to be the same atoms, just rearranged into new molecules. Okay, cool. So let's talk about how to actually balance a chemical equation. So the first thing we're going to do to balance a chemical equation is we're going to make an inventory of what chemicals are in the reaction, and how many are either on the reactant side and how many are on the product side. Then we're going to pick an element in that reaction, and we're going to look at which side has less, and we're going to increase the coefficient on the compound that element is found in, so that we increase the number of that element present to make it balanced. And so we want to make sure that we pick an element that is only found in one compound on either side of the reaction. If it is present, for instance, in 2 places on the product side, we want to ignore that compound and try balancing that one out last. And so we're going to go through each element that is in the reaction, working to balance those out by increasing coefficients on one of the compounds in the equation. And so again, if a compound is found in more than one element or compound, I should say, on either side of the reaction, we want to work on balancing that one last. So, and we might get to a point where we've looked at balancing each of the elements, and it's still not balanced. We want to just keep going through our elements in the same order, working on balancing things out until we get to a nice, happy, balanced equation. So let's look at an example, and we'll go through these steps. So first things first, we need to make an inventory of all the elements in this reaction. And how many are on both sides. So we've got nitrogen and hydrogen, and I've got 2 nitrogens in this compound here, or rather this is an element, and I've got 2 hydrogen atoms in this guy here, and in this compound there's 1 nitrogen atom and 3 hydrogen atoms. So this is not balanced right now. We have imbalance. So I'm going to pick an element, and I'm always going to start with the first one I see in the reaction, unless it's found in more than one place on both sides. But this is not. Nitrogen is in N2, and it's in NH3, and that's it. Good. So I've got 1 nitrogen over here and 2 nitrogens over here. So I'm going to increase the coefficient on one of these compounds to make sure that it's balanced. I want to increase the coefficient over here to make this so that there are 2 nitrogens. So I'll put a 2 as my coefficient there, and that changes this. So now that I have 2 nitrogens. It also has affected the amount of hydrogen. So by making there 2 nitrogens, I've also made it so that there are 6 hydrogens here now. 2 times 3, giving me 6 hydrogens. Well, nitrogen is balanced, so I can move on to the next element in the equation, and that's hydrogen. And I need to increase the coefficient on one side to make sure that it's balanced. So if I've got 6 hydrogens here, I will increase this 2 to make it equal to 6. And I can do that by multiplying it by 3. So I'll put a coefficient of 3 in front of my hydrogen. And so now that makes it so I have 3 times 2 hydrogens, or 6 hydrogens. Nice, and my chemical equation is all sorts of balanced. Awesome sauce. Let's look at another example before we talk about some spicier stuff. So why don't you pause the video, and with what we've just done and our list of rules, why don't you try giving this dude a crack? Pause it, try it out now. Sick, pause it and try it out. Well, let's talk about it together. First things first, let's make an inventory. I've got carbon, hydrogen, and oxygen on both sides of the equation. And it's important to note that my cat just freaked out. It's important to note that my cat just freaked out. And it's also important to note that oxygen is in 1, 2, 3 places. So we're going to want to deal with oxygen last, once we've gotten carbon and hydrogen all balanced out. First thing we want to do is, take our inventory. So I've got 3 carbons, 8 hydrogens, and 2 oxygens on my reactant side. And I've got 1 carbon, yep, that's it. And I've got 2 hydrogens, and I've got 1, 2, 3 oxygens in here. It's important to make sure that we account for it in both places. Okay, so we'll start balancing it out, and I'm going to start with carbon because it's only in one element on our place, rather, it's in one compound on either side. And so since I've only got 1 carbon over here, I want to increase that to 3. So I'll put a 3 as my coefficient in front of CO2. And I will make changes here to note that my carbon is now 3, and my oxygen has changed as well. I now have 6 oxygens here, plus another one over here to give me 7 oxygens. Okay, carbon is balanced. Let's balance out hydrogen. There are 8 hydrogens here and 2 on this side, product side. So let's make it so we have 8 on the product side. We'll put a coefficient of 4 in front of H2O because 4 times 2 hydrogens gives me 8 hydrogens. And this again is going to affect our amount of oxygen. We now have 6 oxygens, 3 times 2 giving us 6 from CO2, and we have 4 oxygens over here, 4 times the 1, so 6 plus 4 gives us 10 oxygens total. Well, last up, we can balance oxygen because our other 2 friends are balanced out. So we have 2 oxygens on this side to our 10 over here. We want to have 10 on this side, so we'll put a 5 in front of this O2. 5 times 2 oxygens will give us 10 oxygens total, and now we have a happy balanced equation. Awesome sauce. Here's some baby platypuses. Oh my gosh, look how cute they are. They are so adorable, but their terrifying claws are a little bit terrifying to me and a little menacing looking. This guy over here. Anywho, if we have polyatomic ions in the chemicals that we are reacting, polyatomic ions, we're going to treat them like they are one single element. Even though they are made up of multiple atoms, we're going to treat polyatomic ions like they are one thing and not break them into their separate atoms. So, looking at this equation, if we were going to balance this dude out, when I'm taking my chemical inventory, I'm going to say SO4 is just sulfate, SO4. And I'm going to say that nitrate is NO3. I'm not going to break that up into nitrogen and oxygen. That would be a real big pain in the butt. And it works better when we don't do that. So why don't you take a crack at balancing this equation out? Okay, cool. Well, let's go through it together. We've got 2 sodiums on our reactant side, 1 sulfate, 1 aluminum, and 3 nitrates. On our product side, we have 1 sodium, 1 nitrate, 2 aluminums, wow, and 3 sulfates. Oh, wow, look at that. Oh, I went in a different order from what I said here. Whatevs. Anyway, let's work on balancing this. Since every element and also our polyatomic ions only appear in one thing on either side, we can just go through this down the line, easy peasy. So we'll start with sodium. I've got 2 sodiums over here, and I've got 1 over here. Let's slap a 2 coefficient there, and that's going to change my number of sodiums and my number of nitrates, both of those being 2 now. 3 sulfates still, 2 aluminum still, and now we have 2 nitrates. Okay, cool. So the next thing I'm going to do is I'm going to balance out my sulfates. And so I threw a 3 in front of the sulfate over here because I've got 1 sulfate, and I've got 3 on this side, so I got to fix that. Now, you might be saying, dude, that's going to mess up our sodium, which it will. We'll now have 6 sodiums on this side and 3 sulfates, still the same number of aluminum and nitrate. And you might be like, dude, we just balanced out the sodium. Why are you going to do me like that? But don't worry, if we just follow the process and keep going through, everything should work out in the end. So sulfate is balanced. Let's go down to aluminum. Aluminum, we've got 1 on this side and 2 on this side. So let's slap a 2 coefficient in front of our homie here. And that'll give us 2 aluminums on this side. So if we go through the list again, we still have 6 sodiums. We still have 3 sulfates. But now we have 2 aluminums and 6 nitrates. Oh my goodness. Okay, well, aluminum's balanced and sulfate is balanced. Let's take care of nitrates now. If we've got 6 nitrates on this side and only 2 on this side, we want to make this so that we have a full 6 nitrates on this side. So let's slap a 6 coefficient in front of this friend here, and that's going to change our amount of Oh, sodium. Now we've got 6 sodium. We still have 3 sulfates and 2 aluminum, but now we have 6 nitrates, and look at that. Everything is balanced because we just stayed the course. So while you're balancing things, if one of your elements comes out of balance as you're going through the process, don't worry about it. Just keep going. Let's look at one more example because I want to talk about one final thing. If you have two numbers, like if you had 2 sodiums or something on one side and 3 sodiums on the other side, and you can't balance those nicely, you can't just multiply this by 1.5 because we always want to have whole number coefficients. What you can do is find the smallest common multiple, so you can make it so that you have 6 on either side. Let's look at an example with this now. For this reaction here, I really quickly threw together the inventory. And let's start with chlorine because each one of these is found in only one place on either side. So we can start with chlorine if we want to. I've got 3 chlorines on this side and 2 chlorines on this side. If I want to balance out my chlorine right away, what I can do is find the least common or smallest common multiple. So 3 times 2, smallest common multiple is 6. I will make it so I have 6 chlorines on either side of the reaction. So to do that, I will slap a 2 in front of my FeCl3, and I will put a 3 in front of my CaCl2. So this makes it so that I have 2 times 3, or 6 chlorines on the reactant side, and 3 times 2, 6 chlorines on the product side. It's also going to affect the amount of calcium I have and the amount of iron. So now I have 2 irons and 6 chlorines on the reactant side, and I have 6 chlorines and a happy 3 calcium on the product side. Cool. So let's just finish balancing this now, and I'll just keep going down the list. Let's balance out calcium. If I want to have the balanced out calcium, I need to have 3 on either side. So I'll also have a 3 coefficient in front of my calcium oxide. And this is cool because that'll affect my calcium and my oxygen, bringing those both to 3 on the reactant side, and everything's balanced. That was a super chill problem. Anyway, that's the end of this video. I hope you understand why balancing chemical equations is important, because you are not the blue dude from Watchman. And I hope you also feel good about how to balance chemical equations. Ta-ta, and have a great rest of your life.